Hello friends, today we are going to start with the new chapter, that is multi-threaded programming, in short multi-threading in Java. So now we will start with what is multi-threading. Multi-threading is a specialized form of multitasking. So doing multiple tasks parallelly at the same time. A multi-threaded program contains two or more parts that can run concurrently. So more than one part can run simultaneously at the same time or concurrently. Each part of such program is called a thread, like a thread, needle, and thread. A thread is separate thread, and each thread defines a separate path of execution. Understanding multitasking. So we will start. We have started what is multithreading. Multithreading is a specialized form of multitasking. But what is multitasking? We have to understand it first. For that, there are two types of multitasking: process-based multitasking. First is process is in essence program that is executing. The program under execution is called as process. Thus, process-based multitasking is the feature that allows your computer to run two or more programs concurrently. When program is in running state, so process-based multitasking does what? It allows your computer to run multiple programs at the same time or concurrently. For example, it enables you to run the Java compiler at the same time that you are using a text editor. So text editor is running in front, Java compiler is running in background, and so on. So multiple tasks can be run concurrently. Program is the smallest unit of code that can be dispatched by the scheduler. So program is the smallest unit. So it is indivisible part or smallest unit of code that can be dispatched by the scheduler. So scheduler will decide how much time in milliseconds or seconds to allot for each and every program that is under execution. So for example, there are 5 minutes your computer is running. So every or 60 seconds your computer is running at the same time. That 60 seconds will be divided, for example, for 3 processes or 3 programs. It will divide 20 seconds for each and every program. So we will think that all the programs are running at the same time or concurrently. Thread-based multitasking. In a thread-based multitasking environment, thread is the smallest unit of dispatchable code. In process-based multitasking, program is the smallest unit of dispatchable code, and in thread-based multitasking, thread is the smallest unit of dispatchable code. This means that a single program can perform two or more tasks simultaneously. Okay, so in a computer, multiple programs that they have given example like a Java compiler in a background and text editor in a foreground. So these are the programs under execution. But that programs also can be divided into multiple parts. So that single small parts are called as thread, and these threads are the smallest unit of dispatchable code in thread-based multitasking. And in that multitasking type, single program can run or perform two or more tasks simultaneously. Each and every part is divided into parts, and those parts can be run concurrently. For instance, a text editor can format text at the same time that it is printing. So formatting is done at the same time while it is printing, as long as these two actions are being performed by the two separate threads. Okay, so one separate thread, one separate module of execution is running separately, and another part is running separately, so that whatever is being printed will be different thing, and whatever text that is getting formatted will be the different thing. The process-based multitasking deals with the big picture, and thread-based multitasking handles the details of that big picture. So we will see the differences between this process-based and thread-based multitasking. Processes are heavyweight tasks that require their own separate address spaces. Threads are lightweight. So processes are heavyweight and threads are lightweight. This is the basic difference. They share the same address space and cooperatively share the same heavyweight process. In process-based multitasking, inter-process communication is expensive and limited. Inter-thread communication is inexpensive in thread-based multitasking. So first difference is processes are heavyweight tasks and threads are lightweight tasks. Second difference is inter-process communication. Means when multiple processes are running simultaneously, like Java compiler is running in background and text editor is running in foreground, as the example we have seen. The communication between those two processes is expensive. It's highly expensive and communication rarely takes place or it is limited. Inter-thread communication is inexpensive because in the same process, in a same program, we have divided it into multiple parts and those multiple parts are called as threads. So it is very much inexpensive to communicate between the same parts of same process or they are called as same threads. Context switching from one process to another is also expensive or costly. Why? Because for context switching, each program is a different thing. Each process is a different thing and switching between them is very much costly. Context switching from one thread to next is a low cost because it is contained in the same address space. They share the same address space. They have the same process in execution. Process-based multitasking is not under the control of Java, but thread programming or multi-threaded multitasking is under the control of Java programming. So these are the differences between process-based and thread-based multitasking. Advantages of multithreading. Multithreading enables you to write very efficient programs that make maximum use of CPU because idle time can be kept to minimum. Very efficient program means same program or same process is divided into multiple parts and those parts will make the maximum use of CPU because idle time can be kept to minimum. This is especially important for the interactive network environment in which Java operates because idle time is common. Network environment means internet environment and which is interactive. In that idle time is common and in that idle time can be kept to minimum and for by using the idle time minimum you can make the maximum use of CPU. For example, the transmission rate of transmission rate of data over network is much slower than the rate at which computer can process it. Okay, when you are transferring data from Gmail or WhatsApp or anything that is using internet, it's much slower than you are doing it in a local PC or a computer that you are having. So this is the difference. And in interactive in network environment, idle time is common and Java enables you to keep that idle time as minimum as possible. Even local file system resources are read and written at much slower pace than they can be processed by the CPU. Local file system resources are read and written means local file system resources mean your files, PNG files, videos are read and written at much slower pace than they can be processed by the CPU. And user input is much slower than the computer. So whatever is done internally in the computer, local computer is much faster than the whatever you are taking from the outside. User input is taken from outside. Data transmission over the network is done outside. So whatever is done outside is slower than whatever is done inside of the computer. In a single threaded environment, your program has to wait for each of these tasks to finish before it can proceed to the next one. Single threaded environment means you are doing a single task at a time and unless and until that task has been finished you cannot go for the next task even though the CPU is sitting idle most of the time. In that single threaded environment your CPU idle time will be greater and you have to wait. Multithreading lets you gain access to this idle time and put it to good use. So using multithreading, what you will do? you will keep your CPU idle time as minimum as possible. So you can gain the as much advantage of your CPU time as you can. Windows operating system is a good example of multi-threading. Like you are, for example, you have opened internet and you are downloading some file from your mail, and it is running in the background. Same way, say at the same time you are writing some text into Microsoft Word, or you are painting at the same time, or you are running a song in the background that you can be hearing. So Windows operating system is a good example of multi-threading. In Java, all the class libraries are designed with multi-threading in mind. So whatever class libraries are inbuilt in Java, they are designed such a way that multi-threading can be done. So at the same time, multiple programs can run concurrently. Java uses threads to enable the entire environment to be asynchronous. Rest of CPU cycles are safe. So why Java is using threads to enable the entire environment to be asynchronous, and rest of CPU cycles are safe. So CPU idle time is as kept as minimum as possible. First of all, we will see the disadvantages of single threading. Single threaded systems use an approach called an event loop with polling. In this model, single thread of control runs in an infinite loop, polling a single event queue to decide what to do next. So whatever thread or whatever task you are doing in this time, or at the current time, it will run in infinite loop because it is not knowing about what to do next. So it is waiting till the CPU is telling it to do what is next. Once this polling mechanism returns with, say, a signal that a network file is ready to be read, then the event loop dispatches control to the appropriate event handler. Until then, your event handler returns, nothing else can happen in the system. For example, network file is downloaded from the internet. So single-threaded environment, your environment, it will sit quiet. It will keep quiet. It will wait until that file is getting downloaded completely. After that, when that download has been finished, it will keep idle, and then it will dispatch the control to the appropriate event handler. Like if you are downloading, for example, PDF file, and it is, for example, 20 to 200 to 300 MB. Okay, and you are running on the mobile data, for example, it is very much slow. Unless and until your entire file is downloaded, your system cannot do anything. It will wait, and after the entire PDF file is downloaded completely, then it will do, it will return the control to the appropriate event handler. And until this event handler returns, nothing else can happen in the system. When a thread blocks, that is suspends execution because it is waiting for some resource, the entire program stops running. When in the single threaded environment, if it is suspending execution because it is waiting for some resource, if the waiting time is too much, it can suspend, that thread can suspend, and entire program stops running. So if nothing is happening in the background or in the foreground for the more time, the entire program will stop running. Now we will see the multi-threading advantages over single-threading environment. Main loop or polling mechanism is eliminated. One thread can pause without stopping other parts of your program. So polling mechanism is completely removed. One thread can pause without stopping other parts of your program. So multiple threads can run concurrently. Each and every thread will given a separate slot of time. For example, 20 seconds, 30 seconds, and so on. And one thread can halt in between without stopping the other parts of your program. So each thread is having simple task, and it can be run fast rather than doing or completing one big task at a same time. For example, idle time created when a thread reads data from the network or waits for user input can be utilized elsewhere. Idle time created when a thread reads data from a network. So halting time or stopping time, idle time is created when thread reads data from a network until the data is read completely or waits for the user input can be utilized elsewhere. Multithreading allows animation loops to slip for a second between each frame without causing the whole system to pause. So between each frame, a second halt of a second can be done without causing the whole system to pause. When a thread blocks in a Java program, only the single thread that is blocked pauses. When a thread blocks in a Java program, unlike in a single-threaded environment, if a thread blocks in a Java program in multi-threaded environment, only the single thread that is blocked pauses. All other threads continue to run so that your program does not crash. Thread states. A thread can be running. So we will see in short the thread state. Each and every state can be understood in upcoming slides. A thread can be running state. It can be ready to run as soon as it gets CPU time. A running thread can be suspended, which temporarily suspends activity. Suspended thread can be resumed, allowing it to pick up where it left off. Thread can be blocked when waiting for a resource. At any time, a thread can be terminated, which halts its execution immediately. Once terminated, a thread cannot be resumed. So these are the thread states. Now we will see the priority of the thread. Thread priority are integer values that specify relative priority of one thread to another. Higher priority thread does not run any faster than lower priority thread if it is the only thread running. Okay. So if higher priority will not run any faster than lower priority thread when only a higher priority thread is running at this particular time. So its time will be as same as your lower priority thread. Context switch. A thread's priority is used to decide when to switch from one running thread to the next. The priority will tell the compiler or CPU, a thread compiler context switch. In context switch, its priority, thread's priority will tell the compiler, Java compiler, to decide when to switch from one running thread to the next thread. The rules can determine when a context switch takes place are simple. Thread that voluntarily relinquish control. This is done by explicitly yielding, skipping, or blocking on a pending input-output. A thread can voluntarily relinquish control, and this control relinquish can be done by explicitly yielding, slipping, or blocking on pending input-output. All the other threads are examined, and the highest priority thread that is ready to run is given the CPU. So multiple threads are there. Whichever thread is having the highest priority will be given the access to the CPU. A thread can be preempted by a higher priority thread. A lower priority thread does not yield the processor is simply preempted no matter what it is doing by a higher priority thread. So if it is not relinquishing control or it is not removing control over the CPU and it is the lower priority thread, in that case, thread can be removed explicitly or preempted. So explicitly by force, it will be removed or relinquished control. It is forced to remove the control over the CPU or simply preempted no matter what it is doing by a higher priority thread. Because higher priority is the higher priority. No matter whatever the lower priority thread is doing, higher priority thread will be given the highest priority. As soon as higher priority thread wants to run, it does. This is called preemptive multitasking. Then, in cases where two threads with the same priority are competing for the CPU cycles, the situation is a bit complicated. For operating system like Windows, threads of equal priority are time sliced automatically in round robin fashion. So same priority threads are existing at the same time. In that case, each and every thread will be given a same time slot in a round robin fashion. For other types of operating system, threads of equal priority must voluntarily yield control to that peers. If they don't, the other threads will not run. Other operating system like unlike Windows, other than Windows, if equal priority thread is given the CPU. For example, there are two threads A and B. Both are having same priority. Both may be having high priority or both may be having low priority. In that case, if that operating system is not Windows operating system, what they must do, they voluntarily yield control to their peers. So after some time, it will give the control to their peers. And if they will not give, the other threads will not run. They will be waiting and waiting. Probability problems can arise from the differences in the way that operating system context switch threads of equal priority. So equal priority context which can cause the probability problems of different operating system. Okay. Then synchronization. Because multithreading introduces an asynchronous behavior to your programs, there must be a way for you to enforce synchronicity when you need it. So there must be understanding. What is synchronization? Understanding between the two. Okay, two threads or multiple threads, whatever there are existing in your program at the same time. So multi-threading is introducing us what? Asynchronous behavior. And what we need to enforce synchronicity. For example, if you want two threads to communicate and share a complicated data structure such as linked list, you need some way to ensure that they do not conflict with each other. So whatever linked list is getting modified, that data can be stored in the second thread. One thread is modifying, second is reading. When one is modifying, other should stop and wait unless and until that modification is done. And when modification is stopping, reading is done. So modification one should stop or wait for the reading uh, task is completed. So they do not conflict with each other. They should not conflict with each other. So both threads should communicate in a better way. That is called as synchronization. You must prevent one thread from writing a data while another thread is in the middle of reading it. And for this purpose, Java implements an elegant twist on an age-old model of inter-process synchronization, the monitor. So what is the solution Java has been introduced? That is monitor. The monitor is a control mechanism first defined by C.A.R. Howrey. You can think of a monitor as a very small box that can hold only one thread at the same time. So, to enforce when multiple threads are running and to enforce only one thread to be run at the same time, what it have to do? It have to give that thread to the monitor. So, monitor locks that thread, and if that thread is running, all other must be waiting. Once a thread enters that monitor, that is called as very small box. You can think of a monitor as very small box that can hold only one thread. Once a thread enters a monitor, all other threads must be waiting until that thread exits the monitor. So conflict will not occur. In this way, a monitor can be used to protect a shared asset from being manipulated by more than one thread at a time. Okay. So complicated data structure like linked list. Okay, you are putting a data at the head, at the front, at the back, in the middle, and at the same time another is going and reading, and another thread is coming and displaying the data to the user. It is not allowed, and this structure will be saved by using of monitor. Most multi-threaded systems expose monitors as objects that your program must explicitly acquire and manipulate. So, multi-threaded system like Java expose monitors as objects. So they treat monitor as an object that your program must explicitly acquire and manipulate. So each and every thread should explicitly acquire the monitor. After that completion of that particular thread or the time period time period that is given in round robin fashion is relinquished control. Then after that, the second thread will come and enter the monitor. After the second thread's time is done, it will relinquish control and third one will go inside it. Java provides a clear solution. There is no class monitor. Instead, each object has its own implicit monitor that is automatically entered when one of the object synchronize method is called. So what Java has provided? A cleaner solution. And there is no class called monitor. Instead, each object has its own implicit monitor that is automatically entered when one of the object synchronize method is called. How it is achieved, we will see in the upcoming slides. Once a thread is inside synchronized method, no other thread can call any other synchronized method on the same object. So each and every object has its own implicit monitor given and it is automatically entered. Okay, automatically entered inside the that monitor. Once a thread is inside that synchronized method, no other thread can call any other synchronized method on the same object like monitor. This enables you to write very clear and concise multi-threaded code because synchronization support is built into the language. We are thinking monitor as a box. So Java provides what? Each object will have its own implicit monitor, and once a thread is inside that particular synchronized method, no other outer thread in multi-threaded environment can call other synchronized method at the same time and the same object. This is the solution provided by Java. Now messaging. After you divide your program into separate threads, you need to define how they will communicate with each other. So there should be some way to communicate in between the threads. When programming with most other languages, you must depend on the operating system to establish communication between threads, and this will add the overhead in terms of time, in terms of efforts. Okay, so in other operating system, other languages than Java, what you have to do, you have to depend on operating system to communicate between the threads. And to tell the operating system, you will tell the operating system, then operating system will let you communicate in between your threads, and it will add the time required, it will add the efforts required. By contrast, Java provides a clean, low-cost way for two or more threads to talk to each other via calls to predefined methods that all objects have. Low-cost way means in the multi-threaded environment itself, it is giving the messaging, so that using messaging you can communicate between the threads. Now, Java's messaging system allows a thread to enter a synchronized method on an object and then wait there until some other thread explicitly notifies it to come out. Okay, so in Java's messaging system, once a thread is entered into synchronized method, it will wait for some other thread to call it to come outside. A thread class and runnable interface. Thread encapsulate a thread of execution. Okay, so very small of part of execution, very small unit of dispatchable code in multi-threaded environment is a thread. Since you can't directly refer to the ethereal state of a running thread, you will deal with it through its proxy, a thread instance that spawned it. So how you will access to that thread? Using the thread object or thread instance. To create a new thread, your program will either extend a thread or implement a runnable interface. We will see the both methods. Now, these are methods: get name, obtain a thread's name; get priority, obtain thread's priority; is alive, determine if a thread is still running; join, wait for the thread to terminate; run, entry point for the thread; skip, suspend a thread for a period of time; start a thread by calling its run method. So these are the methods of multi-threading. then main thread that started the execution. When a Java program starts up, this thread begins running immediately. The main thread is important for two reasons. First reason is it is the thread from which other child threads will be spawned. So from the main thread, you can create a multiple child threads. Often it must be the last thread to finish the execution because it performs various shutdown actions. So main thread will be the first thread. After that, other child threads will be created, and it must be the last thread also to finish execution because it has to perform various shutdown actions. Although the main thread is created automatically, main thread is created automatically. When your program is started, it can be controlled through a thread object. Okay, so if you are thinking that how I can control that main thread that is automatically called and automatically created, how I can control or how I can access. You can access it using the thread object. To do so, you must obtain a reference to it by calling the method current thread, which is a public static member of the thread. So how to gain the access or reference of that by using the method current thread. Its general form is shown here, static thread current thread. Once you have a reference to the main thread, you can control it just like any other thread. So what is the general form? Static thread current thread. It will return the thread that is running current thread, and after getting the reference of the main thread, you can control it or manipulate it just like any other normal thread. Now we will see the examples of threads. Start with the main thread. Thread T is equal to thread dot current thread. It will return the current thread and it will save it to the object T. Current thread colon T, it will print the thread, then change the name of thread, and after name change I can again print the thread. So T dot set name my thread. Now for n 5 times I am printing that n, and I am calling the thread to sleep for 1000 milliseconds. Then interrupted exception, if in between any user comes and press the enter button or press any other button, that exception can be interrupted. That thread can be interrupted in between. In that case, I will print exception main thread interrupted. A reference to the current thread, the main thread in this case, is obtained by calling the current thread. And this reference is stored in the local variable t, like I have explained. Program then calls the set name to change the name of the thread, and it is redisplayed. Next, a loop counts down from 5, 4, 3, 2, 1, pausing 1 second between each and every line. The pause is accomplished by the sleep method thread.sleep 1000. The argument to sleep specifies the delay period in milliseconds. So 1000 for 1000 milliseconds means 1 second it will wait. And in between, if I or any user press the enter button, it will get interrupted, and interrupted exception will be caught. In a try catch, a sleep method in thread might throw an interrupted exception. This will happen if some other thread wanted to interrupt this sleeping one. The example will print a message if it is interrupted. In a real program, you will need to handle this differently. So for this type of interrupted exception, you may need to handle it differently rather than only printing the message that interrupted exception is occurring. Here is the output of the output generated. Current thread, which is given a name as main, and after name change, my thread 5 main and 5 4 3 2 1. After 1 second halt, it will print all the numbers. This displays in order name of the thread, its priority, and the name of its group. So name of the thread main, its priority 5, and name of the group is main. Here I have changed the name t.set name my thread, comma 5, comma group name. Okay, so this is called as priority. By default, name of the main thread is main, its priority is 5, which is the default value, and main is also the name of group of threads to which this thread belongs. A thread group is a data structure that controls the state of the collection of threads as a whole. After that name of thread is changed, T is again output. Thread group is a data structure that is a group of threads that control the state of the collection of threads as a whole. So, group will handle all the group of threads, all the collection of threads as a whole. After the name of the thread is changed, T is again output and I redisplayed. New name of the thread is displayed again. The sleep method causes the thread from which it is called to suspend execution for the specified time in milliseconds. So there are two forms of sleep method: static void sleep and static void sleep long millisecond and integer nanosecond. This will also throw interrupted exception and this will also throw interrupted exception. So we will see in detail the number of milliseconds to suspend is specified in milliseconds. So this method may throw an interrupted exception. Whatever number of milliseconds we have provided, it will convert it into second, and for that particular number of seconds, it will sleep. And here, it allows you to specify the period in terms of milliseconds and nanoseconds. This form is useful only in environment that allow timing periods as short as nanoseconds. So very accurate time is required in that environment. In that cases, this sleep will be used. In general, very famous form of sleep that is used, it is called as sleep long millisecond. Now, you can set the name of a thread by using set name. You can obtain the name of thread by calling get name. These methods are member of thread class. Set name and get name. So set name will set the name of the thread and get name will return the name of the thread. Now we will see how to create a thread. You create a thread by instantiating an object of type thread. You can implement the runnable interface or you can extend the thread class itself. The following two sections we will see implementing runnable. The easiest way to create a thread is to create a class that implements the runnable interface. Runnable abstracts a unit of executable code. Create a class that implements the runnable interface and runnable abstract the unit of executable code. You can construct a thread on any object that implements the runnable interface. So runnable is a unit of executable code and it is the interface. Okay. So for that any object that will implement runnable, you can construct a thread on that particular object. To implement it, runnable interface, a class need only implement a single method called run, which is declared like this: public void run. So whatever you will be writing into run, that will be called when the thread is started to run. Inside run, you will define the code that constitutes the new thread. So what that thread is going to do, for example, that thread is going to read the file, or it is opening to file, or it is running the particular file, execution of exe file, or reading the PDF file, or anything that you can write into that run method. And that run will start when after your thread start run. It is important to understand that run can call other methods, use other classes, and declare variables just like a main thread can. So it has all the possible ways to operate, like call other methods, use other classes, and declare variables just like a main thread can. The only difference is that run establishes the entry point for another concurrent thread of execution within your program. So what difference is that this run that you are calling, it will establish the entry point of another concurrent thread of execution within your program. This thread will end when run returns. So whatever that you are writing into the run method, it will be called after thread.start. After you create a class that implements runnable, you will instantiate an object of type thread from within that class. Thread defines the several constructors. The one that we will use is shown here: thread, runnable thread object, string, thread name. In this constructor, Thread object is the instance of a class that implements the runnable interface. This defines where execution of the thread will start or begin. Thread name is the name of the thread. After new thread is created, it will not start running until you call t.start. It is very important because sometimes you have understood the complete threading. Or you are implementing a run method, you are implementing the runnable interface, you are implementing its run method, and you are writing the code. And in the main method, you create the object also. Thread t is equal to new thread. Okay, and after running, you wait for the something to happen. You press on run and nothing will happen. Why? Because you have not called the start method. The start method calling is very important. Instead, you are writing the start, t.start. It will not start running. Start executes a call to run. Run is written, but how to call that run? Using t.start. The start method is shown here, void start. Now we will see the example. Thread t, the new thread default constructor. T is equal to new thread, this demo thread. Then system.out.println child thread t. Then t.start, start the thread. Then second entry point for the second thread, public void run. I is equal to 5, I greater than 0, I minus minus. Child thread I. Thread.sleep 500. Okay. So for 5 times, child thread has been called. Thread.sleep 500. Then catch interrupted exception E. Child interrupted exiting child thread. So 5 times it is called. For 500 milliseconds, that is half second, it will sleep and it will print child thread 5, child thread 4, child thread 3, and so on. And if any other thread is going to interrupt this thread, or you are pressing any button, it will print child interrupted and exiting child thread. Now new thread. So new thread is created for 5 times. It is a main in mains we are writing. Then main thread. In main thread, sleeping time is 1 second. It is also main thread interrupted and main thread exiting. Inside new threads constructor, new thread object is created by the following statement. T is equal to new thread, this demo thread. Okay, and this demo thread is after this creation, it is called start the thread. This line is very much important. If you are not writing this line, your running will not start. T is equal to new thread, this demo thread. Passing this as the first argument indicates that you want the new thread to call the run method on this object, on this particular object. The start is called, which starts the thread of execution beginning at the run method. This causes the child thread's for loop to begin. After calling start, new thread constructor returns to main. No, so now child thread for loop will be begun. Now after that, after calling the start, new thread constructor returns to main. When the main thread resumes, it enters its for loop that is written inside the main thread's run method. Both threads continue running, sharing the CPU until their loop finish. Okay, so they will share the CPU for the particular time. Okay, for the child thread, we have given the sleep time half second, that is 500 milliseconds. And for the main thread, we have given the sleep time as 1000 milliseconds. So child thread will be halting for the half second, and the main thread will be sleeping for the 1 second. Okay, in that particular sleeping time, main thread will try to run, will try to access the CPU and use the CPU time. And when main thread is sleeping for 1 second, in that particular time, child thread will try to complete the cycle. The output produced by program is as follows, and your output depends upon your processor speed and your task load, how many tasks you are doing at the background. So first of all, child threads will be run 2 times because child thread has given, first of all, main thread is run. Main thread will run 1 second. In that 1 second, two child threads can run. because its sleeping time is 500 and main thread sleeping time is 1000. In that 1000, two child threads will run. After its second time is finished, main thread will run and it will display its output. Then 3 and 2. Child thread will run 2 times. Then again main thread will run. Then child thread is 1. Exiting child thread. So child thread is finished up to 1. And then main thread is 2. It will sleep for 1 second. Again main thread is equal to 1. Again it will print the message. Main thread is exiting. So this way proper time slots are given to both the threads depending upon the sleep method that is provided. As mentioned earlier, in a multi-threaded program, often the main thread must be the last thread to finish the running. For each and every program, main thread must be the last thread because it have to relinquish the control or shutdown. It have to perform some shutdown operation. In fact, for some older Java virtual machines, if the main thread finishes before a child thread has completed, then the Java runtime system may hang. Why? Because it's the responsibility of main thread to perform all the shutdown operation, like closing of all files, finishing closing some file handles, and so on. Is this preceding program ensure that the main thread finishes last because the main thread sits for 1000 milliseconds and child thread sits for only 500 milliseconds. This causes child thread to terminate earlier than the main thread. And we will see now the better way to wait for a thread to finish. Unless and until main is a last thread to finish, we will not complete or finish a program. Now we will see the extending thread class. The second way to create a thread is to create a new class that extends thread and then to create instance of that particular class. In the previous example, we seen creating a thread by creating a class that implements runnable interface, and the second method is extending thread class. The extending class must override its run method, which is the entry point of the new thread. It must also call start to begin execution of the new thread. Here is the preceding program for using extending thread class. Class new thread extends thread new thread. Here we are calling super demo thread. Okay, so super is called for this thread base thread class method call constructor call. Then child thread this and child thread dot start. Okay, this is the entry point for the second thread, child thread I, child thread dot speak 500 seconds. Then exiting child thread if the interrupted exception occurs. Then new thread for the main. Then main thread it is sleeping for 1000 milliseconds. Then main thread interrupted, main thread is sleeping. This program generates the same output as the preceding version. The child thread is created by instantiating an object of new thread which is derived from the thread class. So how the child thread is created? Using start method. This is start method call. And output is same as the previous one. Call to super inside new thread invokes the following form of the thread constructor: public thread string thread name, and it will call the this parameterized constructor of the super class, that is thread. Now the question is, which approach is better? Which approach to create a child thread is better, to implement runnable interface or to extend a thread class? A thread class defines several methods that can be overridden by the derived class. Of these methods, only a method that must be overridden by all is run method. This is of course the same method required when you implement runnable. Many Java programmers feel that classes should be extended only when they are being enhanced or modified in some way. Okay, so most programmers think that when to extend a thread class when you are modifying your own thread class, your own child thread class in some way. For that purpose only you should extend thread class. For other things, like any other thing that in that you are not operating on that particular thread, or you are not modifying that thread, you can directly implement the runnable interface. So if you will not be overriding any of the threads other methods, it is probably best simply to implement runnable. Whenever you are modifying a thread object, you can extend thread class. For any other way, for any other purposes, you are creating a class, creating a thread object, you can simply implement a runnable interface. And of course, this is up to you, it is your choice. However, throughout the rest of this chapter that we are going to see, we will create threads by using classes that implement a runnable interface. Now, creating multiple threads. So far, you have been only using two threads, the main thread and one child thread. But you can create as many child threads as it needs. For example, following program creates 3 child threads. You can spawn as many threads as it needs. So we will see this example. New thread implements runnable string name thread t. New thread string thread name. Name is equal to thread name. T is equal to new thread this comma name. So we are creating here new thread, then new thread t dot start the thread. Entry point for the thread dot sleep. This is the run method. Thread dot sleep 1000 milliseconds. Name is interrupted, name is exiting. Okay. So it is a parameterized constructor. Name of the thread is given when you are creating a thread when you are creating the thread object. Then you are giving this particular name to this particular thread. And you are starting, and after start you are printing this name. Now, new thread 1. One thread created whose name is 1. Then thread is created whose name is 2. Then thread is created whose name is 3. Now, wait for other threads to end. Thread dot sleep 10,000 milliseconds, that is 10 seconds, and catch interrupted exception E. Interrupted exception E, and main thread interrupted, main thread exiting. Okay, so this way we have seen multiple things related to your threading, multi-threading, single-threaded environment, multi-threaded environment, what is thread, how to create a thread object, how to create a thread class using a runnable interface, and using extending the thread class. We have also seen the example. In the upcoming upcoming session, we are going to complete the remaining topics related to multi-threading, and after that we will start with the practical part. So meet you in the next session. Thank you so much. So this is the output. 1 2 3 1 2 3. Every thread is sleeping for 1000 milliseconds. Okay, so meet you in the next session. Thank you so much.